Hi, this is a continuation on our lecture on triangles. Last time we looked at some congruence rules. We will continue with congruence rules as of now. So the next congruence rule is called AAS, or angle side congruence rule. It is stated as if two angles and one side of a triangle are equal to two angles and the corresponding side of the other triangle, then the two triangles are congruent. Let's see what it means geometrically. Consider two triangles. Let's name these triangles as ABC and PQR. You have angle P is equal to angle A, and you have angle C is equal to angle R. So, and you have a corresponding side which is equal. Now, if AC will be equal to PR, then this would not be AS but would be ASA congruence rule. So therefore, which we've already proved before. So therefore, we'll consider some other side. Let's say AB and the corresponding side here being PQ to be equal. Let's look at the proof of this AAS congruence rule, which turns out to be pretty elementary. If you consider the fact that the sum of the angles of a triangle is equal to 180 degrees, this implies angle A plus angle B plus angle C is equal to 180 degrees, and angle P plus angle Q plus angle R is equal to 180 degrees. Now, because angle P is equal to angle A and angle R is equal to angle C, replace angle P and angle R in this equation and rewrite. We have angle A plus angle Q plus angle C is equal to 180 degrees. Let's name this 1 and name this 2. And so therefore, by subtracting uh, 2 from 1, you get angle B minus angle Q is equal to 0. This implies angle B is equal to angle Q. So therefore, from just these conditions, you have angle B is equal to angle Q also. And so now this reduces to a ASA condition, in which angle B is equal to angle Q, angle A is equal to angle B, and AB is equal to PQ. And so therefore, by ASA, triangle ABC is congruent to triangle PQR, and hence prove that AAS congruence rule holds. Now let's look at another congruence rule, which is SSS, which is side side side. It states if three sides of one triangle are equal to three sides of other triangle, then the two triangles are congruent. Basically, it is could be probably called the simplest. Say if this side were equal to this side, and this side were equal to this side, and this side were equal to this side, these two triangles are congruent. Pretty elementary stuff. Now let's look at RHS congruence rule. It states if in two right triangles, which is right angle triangles, hypotenuse and one side of a triangle are equal to the hypotenuse and one side of the other triangle, the two triangles are congruent. It can be stated as such, considering two right angle triangles. And it says if hypotenuse is equal to the other hypotenuse, and if one of the sides is equal to one of the sides of the other, then these two are congruent. How do you go about proving this? Let's say this is triangle ABC and this is PQR. Then we know that by Pythagoras theorem, BC can be found and QR can be found. Now, because AB is equal to PQ and AC is equal to PR, BC is equal to QR by Pythagoras theorem. Let's see how it is written. So we have BC whole square plus AB whole square is equal to AC whole square. And also you have for this triangle QR whole square plus PQ whole square is equal to PR whole square. And we know that AC is equal to PR and AB is equal to PQ. And if we subtract this from this, you have BC whole square minus QR whole square is equal to 0. This implies BC is equal to BC whole square is equal to QR whole square. This implies BC is equal to QR. And so therefore from just the conditions of RHS we will arrive at BC is equal to QR also. And now because all three sides are equal, by SSS rule you have triangle ABC being congruent to triangle PQR, and hence is the RHS congruence rule. Now this is a theorem which states angle opposite to equal sides of a triangle are equal. Consider a triangle and say this side is equal to this side. We have to prove, let's again name the vertices. You have triangle ABC. To prove angle B is equal to angle C, given AB is equal to AC. Right? So how do you go about proving this? Consider angle A and consider the angle bisector of A. Let's say this, and let's say this intersects BC at D. So this angle is equal to this angle, and so therefore in triangle BAD and CAD, AB is equal to AC and AD is equal to AD obviously, and because AD is the angle bisector, angle BAD is equal to angle BAC. Let's write all of this down. AB is equal to AC, which is given. Angle BAD is equal to angle CAD, and trivially AD is equal to AD. This implies by SAS triangle BAD is congruent to triangle CAD. This implies by CPCT, that is corresponding sides of parts of congruent triangles, angle DBA is equal to angle DCA. That is, angle B is equal to angle C. Hence proved. So we have proved that angles opposite to equal sides of a triangle are equal. The converse also holds. The converse being sides opposite to equal angles of a triangle are equal. These are very important properties, especially when dealing with isosceles triangles or equilateral triangles. Next we look at the inequalities associated to triangles. The first one being, in a triangle, angle opposite to the longer side is larger. The angle opposite to the longer side is larger. Say if you have, say, this triangle in which this is visually larger, so then this states that this angle will be greater than this angle, because this side is again visually smaller than this angle. In a triangle, sides opposite to larger, angle is longer, basically the converse of this statement. And also the sum of any two sides of a triangle is greater than the third side. Very important property. So if you have triangle ABC, then the inequalities which can be listed out are AB plus AC is greater than CB, also AC plus CB is greater than AB, and AB plus CB is greater than AC. These three inequalities are basically the mathematical statements for this inequality property. This is all we have to say about triangles. Thank you so much.